Yes,
Yes.
yes. It's
Okay.
very useful.
Okay. I hope you use that as
Yeah.
to refer back to what you don't understand. Okay, because maybe in a very short period of time, I won't be able to show you a lot of things. But if you listen back, probably you'll be able to clear, to clarify what you do not understand. Okay, so what you don't understand, probably you'll be able to see better. Okay. Okay, where's Liang? I cannot see Liang. Okay, but anyway, I hope he's around. Okay. Right. So I think I've already introduced to you inventory management. Okay, inventory management, inventory control, basically inventory control. And uh, I'll show you this. Okay, there's 4 types of inventory, right? You can see, You can see the slides, right? Okay. So you notice there's raw material, work in process, and then maintenance, repair, and finished goods, which are actually the primary types of inventory that exist in organizations, that exist in all companies. So this is typical inventory. So in this top chapter, and I showed you the material flow cycle. Okay, and I asked you, for example, where are for example, the raw material. Okay, raw material, work in process, or this is final product for this cycle. Okay, so I've shown you this, and I think you have an idea of what the material flow, and you can also name this as supply chain. If you go back further, if we go further in front for the uh, upstream. Okay, then you will see like furnitures, and so on. Okay, downstream or upstream. Upstream, yeah. Now, I already introduced to you ABC analysis. Okay, why we need to have ABC analysis is because we need to understand which particular inventory items you need to have greater control. When I say greater control that means you need to monitor the usage. Usage, for example, it is very expensive. You must control how it is going to be recorded in and out from the store, for example. Okay, so this is why we need ABC analysis, and it's very simple, straightforward. You can put it into an Excel, and you can actually do the calculation Excel. And then I think I introduced to you the EOQ, Economic Order Quantity Model. Okay, and I have to remind that it is actually independent demand. Okay, the demand for the item have got nothing to do with the demand of any other items in the inventory. It is standalone. Basically, it's a standalone. It's an independent demand. Uh, okay, so dependent demand is like I gave you the example. If you want to produce, 100 computers, so you need to have enough components to meet the 100 computers. Okay, so that is dependent demand. Dependent demand, we need different type of inventory control. Okay, inventory control or scheduling. Right. So after that, I mentioned that you have holding costs, ordering costs, and setup costs. Okay, setup cost is similar to ordering costs. This is for production. Okay, production. This is for um, normal ordering with no production, consumption only. It's only consumption, usage. For example, you use batteries for the whole year. Okay, so if you know the usage rate per day, then you can actually order accordingly. Okay, based on this EOQ, economic order quantity model, whereby we try to minimize the total cost. Okay, minimize the total cost means minimize the holding cost and the okay, let me show you. Okay, this is, I think probably it is quite difficult to see this initially because this is setup cost or order cost. The order cost will reduce, but this is annual. This is cost. This is increasing. This is increasing as well. Order quantity is increasing. So the more orders that you make, okay, is the more expensive is going to become. The more orders come from the lower quantity that you order. For example, in a year, if you have demand of 1,000 and you order 10 times, so obviously, every time that you order only 100. So that's why the cost is 10x, 10 times some ordering cost. Okay, but if you order only one time, okay, you only order one time, that means it is only 1 times x, so it is lower than this. Okay, so this is your economic order quantity. So where is your EOQ? If this, so this is so-called EOQ basically. This is the optimum, whereby you minimize the total cost, whereby the total cost is holding plus order cost. Holding is going to increase. Holding means you keep the stock. Okay, if you keep more, obviously the cost is going to be higher. So this is the whole concept of EOQ. We try to minimize total cost. Minimize means to make it as low as possible. Today business, all company doing business, they only do two things. Objective is only two. One is minimize cost. And what's the other one? What do you think the other one is? The capitalist objective of business. I've told you one. One is minimize total cost. What is the second objective of all business today? Anyone can answer that. Think about it. Now, I'm asking you, in business today, if I have, products, okay, I try to minimize cost of production, cost of inventory, cost of labor. Minimization of cost is always the objective. First objective. What is the normal, usually second objective of businesses anyway?
To make profit.
Exactly, to make profit. But the word, it's not only to make profit. It's actually to maximize profit.
Maximize profit, right.
Maximize profit. Okay. So when I did my degree, I had to study on linear programming. If you know linear programming, they have some certain objective function. Objective function, y equals to something x1 plus x2 plus 1. And subject to these variables, x1 must be less than certain, x2 must be more than something, x3. So this is optimization. So maximize profit is always the goal of business. So when they model, if you study economics also, you'll see this maximization of profit as well as minimization of cost. Okay, so it's same thing with inventory, or same thing with operation cost, process cost, and so on. Okay, so I hope you get the idea, the idea of actually optimal order quantity. Now, so by minimizing the sum of setup and holding costs, total costs are going to minimize. So you minimize the sum. Sum means total. Sum means total. Total of what? Total of order costs and holding costs. Okay. And this optimal order quantity or size Q star will minimize the total cost. Okay. A reduction in either cost reduces the total cost, meaning a reduction is in ordering, in either cost, in ordering or in holding costs, will reduce the total cost. Okay. And optimal order quantity occurs when holding costs and setup costs are equal. That means when this is ordering cost, this is holding cost, okay, straight line. So this is where it meets. This is where this equals. So this is Q star. Okay. So optimal order quantity occurs when order cost, holding cost meets equal. Okay, are equal. And I've showed you the formula. So this is a formula that is derived from that graph. Okay, from that graph, this is actually how it is derived. And annual setup cost is D over Q times S. And then annual holding cost is Q over 2 over H, which is average inventory multiplied by holding cost per unit per year. Okay, so average inventory Q over 2 Q divided by 2 multiplied by holding cost. And if you solve this, because we say that optimum quantity is when annual setup cost equal annual holding cost. So that means this equals to this. So D over Q times S equals to Q over 2 over S. So we solve for Q. So this is 2 ds. So that's why you get 2 multiplied by ds equals to Q squared H. Okay, this is actually here. 2 multiplied by ds equals to Q squared over 2. Q squared is 2 ds divided by H. Q star. We pronounce it as Q star. We say is this Q star. You know star? Star, huh? Q star. Square root of 2 ds divided by H. You did the homework, I know. I know you have done the homework, but this is just to refresh back, to refresh and understand back. And I showed you the example. So this is what is the optimum number of needles to order given that demand is 1,000, setup cost or ordering cost, the same thing. Setup and ordering cost is similar, same. H is 50 cents per unit per year. So just plug it into formula and you'll get 200 units. Okay, 200 units. Right. And the expected number of orders is given by the total demand, okay, demand divided by the every time you order. If you order 200, of course this 200 is coming from here. So we have decided that we are going to order 200 every time. So your expected number of orders is going to be 5 orders per year. Okay, but of course if the quantity is more, then probably it is more than that. Depend on the demand, depend on the the cost, the cost that you have. Okay, and there is a optimum time between orders, which is number of working days. So you need a new information. You need the number of days, because if you do not know the number of working days a year, okay, in a year, if you have 250 days working, right, and you make 5 orders for the whole year, then obviously every 50 days there is the new cycle. Okay, so one order only lasts you 50 days. 200 units will only last you 50 days. Okay, and of course you can calculate the demand, the consumption per day. So the total annual cost, you can go back to the formula and calculate that using, D divided by Q times S plus Q over 2 times H. So in this case, it is $100. So the total inventory cost in this case, it is $100. Okay. So why you need this? Because you can also do some comparison. What if your Q is different? You can actually test that. You can see that. Okay, so when you want to include the actual cost of material, then you have to have this additional product cost. Okay, price times demand. Okay, price times demand. So that is another, if you want to put inside there. So I think I didn't explain this clearly about robust model. Okay, the EOQ model is robust. What do you mean by robust? Robust. What do you mean by robust? It is explained in the next sentence.
Healthy. It means healthy.
Healthy, strong, etc.
Stable.
Canberry?
Stable.
Okay, stable. Correct. Stable, yes, stable. So it is stable. It is stable. When you say stable, that means this model, it works. I mean, it is still valid if all the parameters and assumptions are not met. That means if you change the Q, for example, you don't want to order just now 200. I want to order 210. So I can just calculate and see the total cost, because the total cost curve is relatively flat in the area of EOQ. That means it is relatively flat. Okay, so that your Q star can be between this range. It's not must exactly at that particular point. Okay, it shows here. So example like this. So if, for example, suddenly your demand is not 1,000. Your demand is not 1,000. Your demand is 1,500. So by using the formula, and I calculate, for example, I calculate Q star at 1,000. When I say here Q star 1,000, you understand, it's 200 units. Q star at 1,500, that means I calculate the new Q star, which is 244. There is a difference between 244 and 200. That means now you're ordering more. You're ordering 245. Okay, of course you cannot order 24.9. You can order 245. Exact number. There is no decimal product. Product is 11111. Anyway, so the ordering of the old Q star here, which is 200. This is the old Q star, gives you a total cost of $125. Okay, that means I still, with the new demand, I still don't want to change to 244. I want to use 200. So it is 125, sorry. And if you order using 245, the change in the price, the total cost is small, negligible. In this case, Now you see here 1,500 divided by 244.9. This is divided by 200. So the change is just $3. That's why it means robust. It is stable. Stable even though demand change. Demand changed quite a lot, 1,500. But I still keep to the 1,000 unit EOQ. The EOQ for 1,000 unit is 200. That means I still order at 200. The cost is 125. But if you still insist on using the new EOQ, which is 244.9, the cost is only 122. The reduction is so small. The total cost reduction is so small. That's what it means by it is a robust model. Even though it is, in real life, this is too simple, in real life, because inventory is very fluctuating, and in this model also, we have not considered discounts, quantity discounts, which I want to go in today. I'm going to show you EOQ plus quantity discounts. Okay, so this is EOQ robustness. It is robust, and if you have the opportunity to use it in in factories, or even in retail shop or in any store, you can use this. This is very good. It's widely used. So it's only 2% less than the total cost of 125 ringgit when the order quantity, not 125 ringgit, $125 when the order quantity was 200. Okay, so it's robust. That's what they mean by robust. Okay, and I also think I did show you a little bit of this because EOQ answers how much or how many to order, but when to order. So this is related to the concept of reorder point. Reorder point means when it go down to how many quantity remaining, how many quantity we should order. I mean, you use from 200 and daily until you use 100, left 100. Should you order? So this is what we call as reorder point. So reorder point is demand per day multiplied by lead time. Obviously, you need to know the lead time. And in this case, lead time is constant, fixed. But in real life, is lead time the same all the time? Is it same lead time? Lead time means I order, then I receive it. Or I order from China, I receive it. Is it always same? 2 weeks, 2 weeks? Not necessarily, right? In real life. It may be 2 weeks, it may be 3 weeks. But in this model, we assume fixed. Okay, fixed lead time. And small d is demand, big demand, the whole year demand divided by the number of working days in a year. So we have this ROP here. So this is our Q star. And for example, start from 200 and we reduce the stock because we use it. Okay, so now it become 198, 196. It will reduce until ROP. And this lead time, because this is days. So the reorder, then it will arrive, then instantaneously it will increase back to our EOQ. And we use it. Okay. So reorder point is given by this formula, and if this is example, so you get ROP to be 96 units for 3 days lead time. 4 days lead time, we get 128. Okay, that is. I'm not going to show you this in detail. I'm just going to brief you only. This is just brief. Production order quantity model. Production order. When you say production order, it means there is production. For example, I produce these components, parts. So there is a production time. But there is a demand time where it's actually being consumed. So this is the production. That means you increase the stock until you reach a quantity, Q star, maximum inventory. then you reduce it. So this is a bit more complicated, okay? It's a bit more complicated, but the same concept is utilized, okay? You still need annual inventory holding cost. You still need annual inventory level and also the maximum inventory level given by these formulas. And I'm not going to go to the detail. There is the number of days in production. And there is the holding cost, production, daily production rate, P, small p. And D is the daily demand rate or usage rate. And it's given by this formula. I'm not going to go into detail also. I'm just going to show you that this is the EOQ or the production order quantity Q star P given by this formula. D is still demand, S is set up. That's why set up, they use set up. When you buy things, it's order, but in production, it is set up cost. You imagine you need to set up the machine. If you want to photocopy, for example, you want to photocopy 100 pieces, of one item. Do you need to set up the photocopy machine? Is there a setup time? Obviously, there is a setup time. You need to, select, you need to see the size and so on. This is setup. You want to, for example, I want to teach this morning. I need to set up. There is a setup cost. There is a setup cost. Okay, I need to set and switch on the computer, switch on my, microphone. I need to connect to the, power supply. I need to. So this is setup. Same in machine. Machine will need to be set up. Okay, and this is there are costs. There is a cost to that, and holding. There's a holding cost. So you only have this additional. Okay. Additional 1 minus D over P, which is actually basically the difference, the different in terms of the stock. That means demand divided by production rate. 1 minus D over P. Just to show you an example. Okay, this is an example. Demand is 1,000 units. Setup cost is $10. Holding cost is 50 cents per unit per year. Production rate, 8 units per day. Demand rate, 4 units per day. Demand rate must not be more than production rate, because if demand rate equals to production rate, it become EOQ model already, because there is no production. Okay, 8, for example, 8 unit per day, demand is 8 unit per day also. Okay, so it become like this. There is no more build up of inventory. So this becomes zero. In this case, we need demand. There is consumption, production, consumption. Okay. So this is in this case, our EOQ is 283 hubcaps. This is something related to car manufacturing, probably the hubcaps used for in tires. Okay. Right. So this is production order quantity, which is also part of inventory control. I'm going to skip this. I'm not going to be bothered with this. This is important for you. This is important. Now, you know what discount is? Quantity discount. Do you know discount? Okay, basically what is discount? Yaakob, what is discount? What do we mean by discount? What is discount?
Discount means actually less amount of the actual price.
Less than the actual price. Lower than the express price.
Lower
right?
than the actual price.
For example, you go to sales, summer sales. It is supposed to be 2,000 yen. And they say 10% discount. How much it become now? So
1,800.
Yeah, okay. So you mean there is a reduced price. So when we buy items as well, buy in quantities, there is a reduced price when larger quantities are purchased, when we buy more. Okay. And of course, we need to trade off. There is a trade-off between reduced product cost and increased holding cost. Why? Because when we order more, we are actually having a higher holding cost. We need to keep more. If, for example, you order only 200, okay, that is our normal EOQ. But now suddenly we say, okay, I want to order 500 at a time. So obviously you need to have a place to keep that 300 more. Correct. If you need, you have extra item, you have to think about where to put it, where to stock it, when is it going to be used. So this is you need to trade off between the product cost and the increased holding cost. But in this model now, a new element is added because we need to know the price. From EOQ just now, we don't have price. Understand? We don't have price. We only have the holding cost and also the ordering cost. So for example, this table shows a quantity discount schedule, meaning that this is if the buyer, they're saying that the seller is going to give you these prices if you order from this quantity. For example, the initial price 0 to 119 is 100 per piece, per unit. If it is if you order 200 until 1,499, I'm going to give you 98, so $2 less. Right? If you order more than 1,500, then I'm going to give you $96. So it depends on company, but of course not all companies will have quantity discount, but I believe many will have. Okay, many will have quantity discount. So how do we model this? How do we actually translate this into our optimum order quantity? Okay, optimum order quantity. So in this case now, we are going to include PD. So total annual cost is setup cost plus holding cost plus product cost. So it is D over Q over S, D divided by Q times S plus Q over 2, which is average inventory, multiplied by, so in this case, we're going to include, this is holding cost per unit per year expressed as a percentage of price. Okay, it is no more going to be just one number, it's going to be so-called IP, basically holding cost per minute per year as a percentage of price multiplied by the price. P is price, P is price plus price times demand. Okay, so if you solve this, you will get the Q star to be square root of 2ds divided by IP, where I is a percent, P is the price, percentage of the price. So we look at an example. We look at an example. Now, but before that, we need to have some steps. Basically, we need to have some rules. Basically rules to actually analyze quantity discount. So it says that the steps that you need to analyze, you start with the lowest possible purchase price. You calculate your EOQ or optimum order quantity until what we call as the first feasible or possible. First possible EOQ is calculated, is found. So you have a few, EOQ basically. So this is possible best order quantity along with all price break quantities for all lower prices. That means every range of quantity, we need to calculate the Q star. Okay. And then secondly, you calculate the total annual cost for each possible order quantity that you have actually determined in the first step. And obviously, you select the quantity that gives the lowest total cost. Okay. So you want to find, basically you say this actually calculate until the first feasible EOQ is found. Let's see an example. Okay. Now, it looks complicated, but don't worry. Don't be don't be afraid. Don't be afraid of this. I think you learn economics also. Have you studied this in economics? Price breaks. Yeah.
Yes.
Okay. So it's nothing new to some of you. So what happened is that okay, this is the first. This is the total cost for no discount. So if you have no discount, this is what it is behaving, the total cost curve. Okay. And so this is the feasible range. So this is when there is discount price, number one. So discount price number one is actually from this point until this point, this quantity. Okay, this quantity. Right? But the lowest Q star is here. Okay, Q star for first discount, okay, first range. So you also have the third range. Or if you have a fourth range, fifth range, it's okay, because it's going to be price breaks. Okay. So you go here for the third discount, the curve is like this. Okay. But the minimum quantity you cannot order here because it will meet the total quantity as well. So it says there, this is possible order quantity. That means at this price break and at this, okay, this what do you call quantity as well. This price break, but this is the minimum quantity. Minimum quantity. Remember our curve, we need to find the minimum total cost. Okay, so this is the scenario for quantity discount models. You have price breaks and then you find the Q for that range. Q star for that range. So Q star for this range is here. This is not Q star, is not acceptable. You need to go to the the next possible price. Quantity. The next possible quantity. Okay, let's see an example. Let's see an example. It doesn't. Okay, let's use the book. I think the book has better. Let me just. If you have the book, if you can open to the page in which it is showing that example, that would be much better. Okay, let me just find the book. Right. And let me tell you what page is it. It is okay, it's going to be on page 545, 544, example 9. Example 9. Let me just share slide with you. Or share the book. Can you see the book? Can you see the book? Or
Yes, we can, but it maybe a little
let me just.
small.
Can you see the book now?
Yeah.
Okay. Right. So I've shown the slide just now was showing this EOQ and possible best order. Let me see whether I can write on this or not. Okay. So I've shown you just now that this is the EOQ. This is a total cost curve for no discount, and this is it is not feasible here. This is not the feasible quantity. Okay, not the minimum cost. Okay, and because looking at minimum cost, because you can see a lower cost here. This is a lower cost, but of course this lower cost, it doesn't meet the quantity, right? So I want to show you the example just now. Oh, sorry. No. Page 545. Okay. Right. So if you this one, so the solution procedure is already explained just now, starting with the lowest possible purchase price in quantity discount schedule and working toward the highest price. Keep calculating Q star from equation 1210 until the first feasible EOQ is found. First feasible EOQ is possible best order quantity along with all price break quantities, okay, for all lower prices. Then you calculate the total cost using the equation. So this is, okay, note that no quantities need to be considered for any prices greater than the first feasible EOQ found in step 1. So this will occur because EOQ for a given price is feasible. If EOQ is feasible, then the EOQ for any price higher than that cannot lead to lower total cost. Okay. So Chris Bechner, let's read this. So that you have context. Stocks toy remote control drones. The store recently offered a quantity discount schedule for these drones. The quantity schedule was shown in table 12.2 and is given. Setup cost is 200 per order. Annual demand is 5,200 units. Inventory carrying cost as a percentage is 28%. Okay. What order quantity will minimize the total inventory cost? Okay, let's do it slowly. Let's do it slowly and see. So we have this information. So first of all, it's of course very important to have that information first. Right. First, so we will follow the two steps approach just now. First, we calculate Q star for the lowest price. Okay, before that, where is the, the price schedule or where is the table 12.2? Where is 12.2? Okay. That means we are using the same this schedule. Okay. So 1 to 119 is 100. 120 to 1,500 is 98. 1,500 above is 96. Okay. So we have this so-called schedule, quantity discount schedule. Now, so we calculate Q star. Q star for the lowest possible price of 96 ringgit. $96, sorry. But the lowest price is 96. So Q star at 96, if you see the asterisk here 96, is using the formula 2 times demand times what do you call setup, okay, or 200, which is ordering cost, 200 divided by percentage 0.28 times price. Remember, I times P. Go back to the formula and see it is actually I multiplied by P, price. So for $96, okay, price, the Q star is 278. Okay, Q star is 278. So because 278 is less than 1,500, so this EOQ is not feasible for the 96 price. So we need to calculate the next Q star. Okay, in the next level, for the next higher level, which is $98. So Q star for $98 is again 2 multiplied by demand times the what do you call, ordering cost or the setup cost divided by the holding cost. In this case, we change to 98. Instead of 96, we use 98. So in this case, we get 275 drones. Okay. So because 275 is between 120 and 1,470, 1,489 units. So this is feasible. Okay, this is feasible for $98. Okay. Okay, you understand or not why 270 feet we cannot use this? Because the minimum order is 1,500. For what? For 96, you cannot order 278. You must order more than 1,500 to get that price. You understand? Okay, because the Q star, this quantity should be more than 1,700, 500. Then only you can get that price, 96. Okay, but in this case, 98. Because the quantity range is between 120 and 1,499. So it is feasible. Okay, this EOQ of 275 is feasible. It is acceptable. Okay. Therefore, the possible price or the quantity are 275 for the first feasible EOQ. And also 1,500, the price break for the lower price of 96. So we need not bother with Q star for the initial price because we found a feasible EOQ for a low price. But you can calculate the EOQ for $100 and you will be able to find, the cheaper, okay, the cheaper. So we do this, we calculate the total cost, okay. So order quantity is 275, unit price is 98, ordering cost is 3,072, holding cost, annual product cost. So the total annual cost is 517,000. Total inventory cost, okay, total inventory cost 517,155. If you order 1,500, remember you cannot order 278 because the price at 96, the minimum order, the so-called minimum order quantity is 1,500 to get this price. So the total cost is 520,053. Oh my God, sorry. So if this what do you call analysis, okay, you continue. It says that I'm going to read this until the end. So because the total cost for 275 is lower, then our order quantity is 275 units. Okay. But if you want to go for 1,500, you still can, if you want to spend that $2,000 more, you can order this. Okay, it's not, it's not a problem to if it's not a problem to the company. Okay. If you read further, even though Bechnel Electronics could save 10,000 in annual product cost by ordering 1,500 units. At the time, it would generate even more than in increased holding cost. So in this example, it is not in the store's best interest to order enough to obtain the lowest possible purchase price units. On the other hand, if the price break quantity for 96 has been 1,000 units, you see, if the price break is 1,000 units, then probably the total annual cost is going to be cheaper than the ordering 275. Understand? We are trying to determine which is the cheapest quantity to order for the whole year. Okay, for the whole year, and how much to actually order, and it's based on discounts. Okay. Okay. Now, why don't okay, I'm not going to be so come back to this. Can you see the slide? You can see the slide back, right? Huh? Can you see the
Yes.
slide? Yeah, okay. So what I've shown you just now is, you know, the method of actually determining the quantity discount. The cheapest quantity, the lowest quantity that will actually meet the discount, you know, schedule. Okay. Any questions? So we can choose the what they call price quantity that gives the lowest total cost. So you buy transcription at 98 units, $98 per unit. So quantity discount variation, all unit discount is the most popular form. That means it depends on you know, units. Or incremental discount. All units mean when we go for sales, you know, it's all units. It's not, you know, unless you know you go buy a certain brand of jeans, buy one free one or buy two free one. So that's different kind of discount. Okay, so you can have all units discount, most popular. Incremental quantity, which actually the example that we showed just now. Remember, it's incremental quantity discount. Incremental, because a certain quantity is what you pay. Fixed fees may encourage larger purchases. Okay, like now today, you look at Shopee, Lazada. You know, they always put the price and they slash, okay, this is the quantity. I don't know whether it's a marketing trick or, you know, a gimmick. Every price that is shown in the Lazada will have a slash. This is the actual price slash 95 slash. So this is you know, a bit confusing. Oh, okay, aggregation over time, over item of times. This, the more that you buy, the you know, the cheaper it's going to be. Or even there's so many variation of discount. Truckload discount, buy one get one free, or just I mentioned just now already. Okay, or one time only sales. So this is happening today. I do not know about this current pandemic. What is going to, how is it affecting? Okay, I want to stop here for you to take a 5 minutes break, and then if after the break, I would like you to, if you, just can just do one small exercise, no submission, just do for this quantity discount, no submission. This is for you to have a feeling of, you know, doing this. You have done it before, is it, Jakob? You have done it before in economics? No? Can't
Economic
remember.
order quantity.
No. The quantity discounts model. Have you ever seen the quantity discount model before in
Which
other subjects?
quantity no.
No. Okay. So
It is.
So go and take your break, and then I'll find one. Unless you don't want to take your break and you want to know which question I want to ask you to probably try out. This is quite simple. Okay, this is 1226. This is quite simple. Or even this 12.22. 12.22.